The expression b squared minus 4ac in the quadratic formula is called the discriminant. So nice and neatly, write down exactly what you see right there. You with me, Marin? Okay, so far so good. Underneath that, go ahead and write, when we graph quadratic equations, they become parabolas. Go ahead and write that down. When we graph quadratic equations, they become parabolas. Let me draw a few parabolas, and you're going to do just quick, dirty, easy, non-Picasso drawing parabolas with me. Okay, they don't have to be art pieces here. When we graph quadratic equations, which we're going to get into next week, veteran students here, they already know how to graph a parabola to a certain degree real quick. But veteran students, don't get cocky or arrogant, because the way we're going to graph is going to be a little more complex, and you got to stay with me and focus. Rookie students, put your seatbelt on. When we graph quadratic equations, they become parabolas. What the heck is a parabola? Well, go and give me an x and y axis really quick. A parabola is like a U-shaped graph or upside down U. Watch this. That's a parabola. How many times did that parabola cross the x-axis? 2 times, huh? So these 2 points, go ahead and put an arrow right here. Go ahead and put x-intercepts. So that parabola that you and I just drew quickly, doesn't have to be a Picasso drawing, that parabola has 2 x-intercepts because it crossed the x-axis twice. Now, stay with me. Watch. I'm going to make a connection between the x-intercepts and the discriminant, this little part called b squared minus 4ac. What's the connection between this, the b squared minus 4ac, and this, what I'm talking about? Watch. Watch, watch, watch. Give me another x and y axis really quick. A simple one. Real easy. Nothing crazy. Look at it like this. Just real easy. One more time. Sure, sure, sure. They become parabolas. A parabola can look like upside down U or a U going up like this. Doesn't matter. Look at the parabola I'm going to draw now. You can draw a quick, dirty one with me. Watch. Look at this parabola. Watch this one. Let me put it in that Dodger blue since they're going to win tonight. Hey, remember last time? I didn't jinx it. They won. Watch this. Watch this parabola. Watch this parabola. Look, it's coming down. It's coming back up. How many times did the parabola cross the x-axis there? 1 point, right? At that point. Look at. Put an arrow here. Put x-intercept. So here it crossed it 1 time, as opposed to the first one we drew. It crossed it twice. So 2 times, 1 time. Last one now. Here we go.
1 time.
Give me one x and y axis again. A quick one. So this parabola crossed the x-axis twice. This parabola crossed the x-axis once, Hernandez. This parabola at the bottom now we're going to draw is not going to cross the x-axis. Look at the way this puppy's going to look. Watch. What if I had a parabola that looks like this? It only crossed the y-axis, huh? But it didn't cross the x-axis. So go ahead and write no x-intercepts. Only a y one. Only a y-intercept. Look at, there's a y-intercept. It crossed the y-axis once, but it didn't cross the x-axis. Okay, so there's three cases. A parabola crossing the x-axis twice, a parabola crossing the x-axis once, or not crossing it at all. Okay, now, here's a kicker now. That's mainly the main lesson, those three situations. This discriminant, b squared minus 4ac, will tell us what situation we're dealing with. Is it a parabola that's crossing twice? Is it a parabola that's crossing once? Or is it a parabola crossing no times? That's what this discriminant is all about. It helps us discriminate between equations that cross twice, once, or 0 times. And that's the end of our notes. Check it out. Put discriminant possibilities. And the discriminant is b squared minus 4ac. And make a quick 3-branch tree map here on your notes. And we're done. I'll give you one example and we're done. Bet? Boo. Go to the office. No. Referral for you, miss. That hurt my feelings. B squared minus 4ac. Watch this now. This is the meat and gravy now. If I do b squared minus 4ac, and if it becomes a number greater than 0, okay, if it becomes a number greater than 0, then I'm dealing with 2x intercepts. Go right. 2x intercepts. Remember how we calculated b squared minus 4ac for warm-up? We got, I think, was it 40? What did we get for warm-up? I can't remember what we got. 8. Negative 8. So it wouldn't be this case. Because negative 8 is not bigger than 0. But if we did do b squared minus 4ac and we got a number bigger than 0, then I know the parabola that I'm dealing with crosses the x-axis twice. It's 2x intercepts. How about if you have b squared minus 4ac and you get exactly 0? What if it becomes 0? Exactly. Then you're dealing, check this out, x, y. Then you're dealing with a parabola, watch this now, a parabola that has 1x intercept. Look at that. Put it right, 1x intercept. 1x intercept. So far, so good, I trust. Questions so far? Move this stuff over here. Have some more room here.
So these are the formulas for each scenario?
Right. These are 3 scenarios. Perfectly said, Gallegos. The first scenario is if I do b squared minus 4ac is greater than 0, then I know the parabola is crossing twice. Second scenario, if it's equal to 0, it crosses once.
Last will be 0 with x intercepts.
And what would be the case here? Beautiful. What do you think this would be? B squared what?
Greater than 0.
That's right here. We already got that, right? That's this one.
That's greater than 0?
That's greater. That's greater. Right. So if you have a b squared minus 4ac less than 0, that's the case Gallegos is already anticipating. We're talking about a parabola. Let me go to x and y axis. We're talking about a parabola that doesn't cross the x-axis. Yeah, this would be a negative, a negative number, right. Less than 0 is by definition negative, right. So we do b squared minus 4ac, it's a negative number. That tells us the parabola is not, look at this, not crossing the x-axis.
What about the y?
It will. Every parabola will cross a y. Every parabola will. Think logically. So watch this. 0x intercepts. Can't fit that in. 3 cases, 3 scenarios. If b squared minus 4ac is a positive number, that means greater than 0. If it's positive, you're dealing with a parabola with 2. If b squared minus 4ac is equal to 0, you're dealing with a parabola with 1 x-intercept. And last but not least, if b squared minus 4ac is a negative number, like we got for warm-up, remember we got -8, Hernandez? You remember how we got -8? That parabola would never cross the x-axis that we're dealing with. Now, we haven't graphed anything yet. We're just doing this before we start graphing. I want you to know what x-intercepts are. So watch this now. One example and we're done. I'm going to prove Murillo wrong. Example 1. Ready? And we're done. How many x-intercepts, I'm going to abbreviate, how many x-intercepts does the parabola have? Now, we haven't graphed yet. I'm not going to have you guys graph any parabolas yet. I'm just going to throw the equations at you, and you need to know how many times it'll cross the x-axis before we graph it, just ahead of time. Here we go. Here's the one I'm going to throw at you. X squared plus 5x minus 10 is equal to 0. If I were to graph this puppy, how many times is it going to cross the x-axis? One time? How'd you do it so quickly? Okay, here's what we're going to do. Let's go to the discriminant. Let's calculate this to see what scenario we're dealing with. Then we'll be able to say how many x-intercepts. You see what I'm saying? So we're going to use b squared minus 4ac, which is called the discriminant, because it helps us discriminate between this situation. What situation are we dealing with? Watch. Okay, the discriminant. B squared minus 4ac. Is it going to be this situation? Is it going to be greater than 0? Is it going to be equal to 0? Is it going to be less than 0? Let's find out. Then once we find out, we'll be able to answer the question. Here we go. Can someone please tell me what my B value is? Awesome. Minus 4. What's my A? Beautiful. C. We're rocking and rolling. Let's do it. Exponents first. So 5 to the second power, 25. Negative 4 times 1 is negative 4 times negative 10. Should I subtract or multiply? So it's going to be a positive 40 plus a 25. 25 plus 40, 65. What scenario am I dealing with? First, second, or third? First. So I know that if I were to graph this equation, which I'm not doing yet, we're not doing that yet, but if we were to graph it, the parabola will be crossing the x-axis twice because it's a positive number. So we're dealing with this situation. Well, right here. If it's greater than 0, Gallegos, then we're dealing with this. If it was equal to 0, we're dealing with that. If it's negative, we're dealing with that. Good question. We're dealing with a positive number, so we're dealing with the first scenario on the tree map here. Questions?